Welcome to Simultaneous Equations Level 5. Pause the video now, have a go at the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving y equals x squared plus 5x minus 2 and y equals x plus 3. Now, the first equation is a non-linear equation and the second one is a linear one, so we need to solve these by substitution. And to substitute, we can take the linear equation, which is written as y is the subject, and because we know that y is equal to x plus 3, we can substitute y into the first equation to create an equation that only has x's in. So the first equation, y equals x squared plus 5x minus 2, becomes x plus 3, because we're substituting y for x plus 3, is equal to x squared plus 5x minus 2. And now we have a quadratic equation. And with quadratics, we always want to solve these equal to 0. So looking at the left-hand side, we can remove the x by subtracting x from the left. And we need to make sure we do the same on the right. And we can also remove the plus 3 from the left by subtracting 3 and doing the same on the right. So on the left, the x, the minus x, the 3 and the minus 3 all cancel out to become 0. And on the right, we have x squared, 5x minus x is plus 4x, and minus 2 minus 3 is minus 5. Now, a really nice way to solve quadratics that just have an x squared at the start is to try and factorise. And to factorise this, we want to come up with two numbers that multiply to make minus 5 and add to make 4. And those two numbers are 5 and minus 1. Because 5 minus 1 is 4, and 5 multiplied by minus 1 is minus 5. So we can factorise this by creating two brackets with an x at the start of each, because x times x gives us x squared, and our two numbers 5 and minus 1 just go at the end of those brackets. So we have x plus 5 multiplied by x minus 1 equals 0. Now, because those two brackets are multiplying each other to make 0, the only way this can happen is if one of the brackets is 0. So either the first bracket, x plus 5, must be equal to 0, or alternatively the second bracket, x minus 1, could also be equal to 0. So we can solve each of these separately to find the value of x. So starting with the one on the left, we can remove the plus 5 by subtracting 5 from the left and doing the same on the right. On the left, the plus 5 and the minus 5 cancel out to give us x, and on the right, 0 minus 5 is minus 5. So x equals minus 5. Looking at the other equation, x minus 1 is 0, so we can remove the minus 1 by adding 1 to both sides, and we have x is equal to 0 plus 1, which is 1. To now find the value of y for each of these values of x, we're going to take the second equation, y equals x plus 3, because y is already the subject and it's the simplest of the two equations, and substitute x into this. So starting with when x is equal to minus 5, this equation becomes y is equal to minus 5 plus 3, and since minus 5 plus 3 is minus 2, y is equal to minus 2, and this pairs with x equals minus 5. We can then move on to our second value of x, which is 1. So when x is 1, y is equal to 1 plus 3, and 1 plus 3 is 4, so y is equal to 4, and this gives us our second pair. So our final solution to problem 1 is x is equal to minus 5, y is equal to minus 2, and x is equal to 1, y is equal to 4. And it's really important that we pair these correctly. In problem 2, we're solving x squared plus y squared equals 41 and y equals 2x plus 3. Again here, the first equation is non-linear and the second one is linear. So what we need to do is take the linear equation and try and substitute this in to the non-linear one. And since the second equation has y as a subject, we can just take 2x plus 3 and substitute this into the first equation in place of y. So the first equation, x squared plus y squared is equal to 41, becomes x squared plus, and in place of y we're going to put 2x plus 3 from that second equation, which still needs to be squared, and that's equal to 41. Now there are different ways of squaring that bracket. What I'm going to do is just write out the bracket twice. So we have 2x plus 3 multiplied by 2x plus 3 is equal to 41. And now I'm going to expand those two brackets. So we have x squared plus 2x times 2x gives us 4x squared, and 2x times 3 gives us plus 6x. 3 times 2x gives us plus 6x, and 3 times 3 gives us 9. So we have plus 9, and it's still equal to 41. We can now simplify the left-hand side by collecting together the like terms. So we have x squared plus 4x squared, which is 5x squared. We have a plus 6x and a plus 6x, which is plus 12x. And we still have the plus 9 on the end, and that's equal to 41. Once again, we've got a quadratic, so we want to make this equal to 0. So we're going to subtract 41 from the right to make that side equal to 0. And we need to make sure we do the same thing by subtracting 41 from the left. So this gives us 5x squared plus 12x, and 9 minus 41 gives us minus 32, and that's equal to 0. Now we could try and solve this quadratic by factorising, but since the number in front of the x squared is not 1, it tends to be easier to use the quadratic formula. And to use this formula, we'll need to establish the values of a, b and c. So a is always a number in front of the x squared, which is 5, b is a number in front of the x, which is 12, and c is the constant at the end, so the one that's just a number. So in this case, minus 32. So substituting this into the quadratic formula, this gives us x is equal to, we have minus b at the top, so that's minus 12, plus or minus the square root of b squared, so that's 12 squared, minus 4 times a, so times 5, times c, which is minus 32, all divided by 2a, so that's 2 times 5. And if we put this into our calculator using the plus on the numerator to start with, we have x is equal to 8/5, or that could be written as 1.6. And if we do the same but use minus in our numerator, we have x is equal to minus 4. So these form the first part of our solution. To find the value of y, we now need to substitute these into one of the two original equations, and the easiest one to use is going to be the second one, the linear one, because y is already the subject and it looks a lot simpler to use anyway. So if we know that y is equal to 2x plus 3, if we first make x equal to 8/5, this then becomes y is equal to 2 multiplied by 8/5 plus 3, and 2 times 8/5 plus 3 gives us y is equal to 31/5. So these two form our first pair. If we now look at when x is equal to minus 4, we have y is equal to 2 times minus 4 plus 3. Well, 2 times minus 4 is minus 8. If we add 3 to that, we get minus 5. So y is equal to minus 5. And these two form our second pair. So our final solution to problem 2 is x is equal to 8/5, y is equal to 31/5, so that's our first pair, or x is equal to minus 4, y is equal to minus 5, and that's our second pair. In problem 3, we're solving y equals x plus 2 and x squared plus y squared minus xy is equal to 5. Now the first equation is linear, but the second isn't. So this means we need to solve these equations by substitution. And look at the simpler equation, the first one. If we know that y is equal to x plus 2, this means that wherever we see a y in the second equation, we can replace it with x plus 2. So the second equation, x squared plus y squared minus xy is equal to 5, becomes x squared plus, in place of y, we're going to put x plus 2. We need to make sure we square that. Minus x, again multiplied by y, so we substitute this for x plus 2, is equal to 5. And we now have an equation that only has x's in. So we need to expand, simplify, and then solve. Now to start, the bracket that's squared can just be written as x plus 2 multiplied by x plus 2. We can expand the next bracket straight away, so minus x times x is minus x squared, and minus x times 2 gives us minus 2x, and that's still equal to 5. We can now expand the two brackets in the middle, so we have x squared plus x times x is x squared, x times 2 is plus 2x, 2 times x is plus 2x, and 2 times 2 is plus 4. We still have to remember that we've got a minus x squared and a minus 2x at the end, and that's still equal to 5. And now on the left hand side, we can simplify by collecting together the like terms. So we have an x squared, a plus x squared, which is 2x squared, but then a minus x squared. So we just have x squared. We then have a plus 2x and a plus 2x, which is plus 4x, but then minus 2x gives us plus 2x. Finally, we have a plus 4 on that side, so we just leave that there, and that's equal to 5. And again, to solve this quadratic, we want to make the right hand side equal to 0. And we can do this by subtracting 5 from the right and making sure we do the same on the left. So the left becomes x squared plus 2x, and 4 minus 5 gives us minus 1. And on the right, the 5 and the minus 5 just become 0. Now, since we have a single x squared at the start of this equation, we can solve this by trying to factorise. And to factorise this, we need to find two numbers that multiply to make minus 1 and add to make 2. And we can't actually find two whole numbers that do this. So what this tells us is that we need to solve this in a different way. And the easiest way to do this may well actually be to complete the square and solve it in that way. But this doesn't tend to be the most common way of solving this. So I'm going to solve this in the more common way, which is by using the quadratic formula. So to start, we need to establish what our values for a, b and c are. Now a is a number in front of the x squared, which is 1. B is a number in front of the x, which is 2. And c is a constant at the end, which is minus 1. So substituting these into the quadratic formula, we have x is equal to minus b, so that's going to be minus 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 1, times c, which is minus 1, all divided by 2a, which is 2 times 1. And if we put this into our calculator using the plus on the numerator, this gives us minus 1 plus root 2, or 0.414, correct to 3 significant figures. If we do the same and put this into our calculator using the minus on the numerator, we get x is equal to minus 1 minus root 2, which is minus 2.41 to 3 significant figures. To find the matching values of y, we now need to take each of these x's and substitute them into one of the original equations. And the best one to use is going to be y equals x plus 2, because it's simpler than the other equation and y is already the subject. So if we take x is equal to 0.414 and substitute it into this equation, we have y is equal to 0.414 plus 2. So y is equal to 2.414, or 2.41 to 3 significant figures. So this is our first pair. If we now do the same with our second value of x, which is minus 2.41, and we substitute it in for y, we have y is equal to minus 2.41 plus 2. And this gives us minus 0.414, again, to 3 significant figures. So this is our second pair. So our final answer to problem 3 is x is equal to 0.414, y is equal to 2.41, and x is equal to minus 2.41, y is equal to minus 0.414.